So basically in this video we are going to break down the reality of 45 days to Mars. So what is it all about and where this all things have started? So back in 2016 scientists have proposed Starshot mission. By that only a team of engineers have developed a theory. Let me take a pause here. I want to note the thing that usually in physics domain or in space domain, when we hear about an article or hear about a theory proposed, we usually hear that that theory was proposed by an physicist. But at this time the thing is different. It is proposed by a team of engineers. uh, so basically they have modified the theory of Starshot mission, and they have made a way through which uh, through that process we are going to travel to Mars within 45 days. So what is the what is the Starshot mission basically? First let us explain that, but before that you can see the timestamps here or in the description box might be about which all topics we are going to cover in this video. So let's discuss about the Starshot mission first. So the Starshot mission was planned back in 2016, and one of the unpopular facts about it is it was funded by Mark Zuckerberg. Okay, by now we knew that Facebook founder is also interested in science domain, towards science domain. So let's keep it a little bit side and focus on our main topic, which was proposed to reach Alpha Centauri, which is the nearest star system to us. It is 4.25 light years away, or somewhat like that. So to reach there by today's technology, it would take 70,000 years. It would take 70,000 years. So basically, to sort out that problem, this project was founded that at least in our lifespan we would get to another star system. And it is theorized that it can travel, it has the capability to travel 20% of the speed of the light. Like, amazing. It has a laser propulsion basically. On the ground or on the earth, the laser beams will be arranged, like they will have much more power. Basically they will project the laser beams towards the star, towards the nanocraft, or which is called as nanocraft because it's just a plate like sailing in the space infinitely, and it has just some cameras or something on board, nothing much heavier than today's missions. So what after that? Engineers have little bit modified it. They have replaced the to increase the payload basically, that astronauts or many payloads will be arranged to go to Mars.
It is similar to the nuclear thermal propulsion system in which the nuclear reactions play their role by transferring heat to the liquid propellant. Now that's obviously a great amount of thermal energy or heat energy, due to which it transforms the liquid propellant into gas which is expelled out by a nozzle, and it provides the required thrust to go up. The only difference here is that the nuclear reactor is now replaced by a laser, which results in enormous amount of velocity or speed. It sounds good, although it sounds good, but practically speaking, it's not a piece of cake.
So basically, before moving forward to into the video, so first discuss why laser propulsion. Like, why only it? Why only we are considering it? We can also consider the chemical rockets which are now used. We can also consider the nuclear rockets. So why not this one? So basically the speed is very lesser, and it will reach around, it will take some around 10 months to reach, and with astronauts and payload it will take some extra time obviously, because more the mass, obviously it will take the more time to reach. But and chemical rockets also need much more fuel, which is impossible to take to such a larger distance with also taking the astronauts as the payload, and again you are putting the propellants into it to the payload. So how it would take, means how it would carry to such a larger distance, that's also the thing. And then comes, why not nuclear rockets, nuclear propulsion rockets? So basically it is not considered as safer means till now, because nuclear, the word suggests that some nuclear reaction would be going inside the rockets. Well, you can say that I will put lead rods into it or something, say, to do it more safer, but you cannot get a good piece of sleep if you are on board on the nuclear rockets, so as an astronaut, obviously. So basically these two things are eradicated and the laser propulsion comes into it.
Okay, so there are several factors to be considered. First of all, arrays of fiber optical lasers are required, which should have enough power to provide desired thrust to the spacecraft. Secondly, it should have high temperature resisting materials, as it is traveling at much greater speed. And the last thing is a highly efficient reflector, so that it can sustain a greater laser power per unit area than a regular photovoltaic panel.
So basically we see here the biggest problem is how to make a material which can withstand so much heat, because the lasers are beamed or projected onto the spacecraft, and then the spacecraft would and then the hydrogen gas would be heated up to 10,000, more than 10,000 Kelvin. Like how to store it? Till now we have no means for it. Like we, one more thing is that we need to spare, we need to place a space station orbiting Mars, like we have here. This is to be placed, as it will deaccelerate the motion. Like they are powering, the lasers are projecting up and it will come into that much speed. To deaccelerate we need something. So okay, it can be replaced by something else also, but to do it, it's not like we are doing it will be done by 2030 25 like that. It's not a speed process. It will little bit it will take time, obviously. So connecting it with Elon Musk is not that. So I like this we conclude our this video. And if you find this video informative, then obviously stay tuned on Astronomer Skills.